Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. We are from College of Engineering, Mechanical Engineering Department, and this is the course for BMM 3521 Fluid Mechanic Lab. The title for this experiment is Friction Losses in Pipes. Our lecturer's name is Sir Muhammad Ammar Nik Mutasim. We are from Group 6, Section 1. My name is Nur Iman Balkis binti Syamsul Kamar and my matrix number is MA19235. Before I proceed with the presentation, I will introduce my team member first. Badrul Amin will present about Chapter 1 and Chapter 3 about introduction, method and procedure. Hanibinda will explain about the theory, and Muhammad Izzuddin and Nurul Amira will explain about the result, discussion, graph and conclusion. Without further ado, I will present the abstract of this experiment. In fluid flow, friction loss or skin friction define the loss of pressure or head that occurs in pipe or duct flow caused by the effect of the fluid's viscosity near the surface of the pipe or duct. For example, internal combustion engines in mechanical system, it refers to the power loss in overcoming the friction between two moving surfaces. The objective of this laboratory is to explain the mechanic of fluid mechanic phenomena in pipes and also understand and apply basic knowledge of major losses in state pipes. The apparatus that are used to carry out this experiment are fluid friction apparatus, hydraulic bench, pressure sensor, data measurement, and data acquisition. At the end of this experiment, all the data such as velocity, Reynolds number, coefficient of the friction and head losses with different conditions and level of degree were studied. In conclude, the solution for friction losses are by reducing interior surface roughness of the piping system, increase pipe diameter of the piping system, minimize the length of piping system, and also minimize the number of elbows, teeth, valve, fitting and other obstruction in the piping system. I will pass to Badrul Amin to explain about the objective of this experiment. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amin Badrul Syam, MA19234. Today I will present the friction loss in pipe 9 for experiment 3 on introduction and methods. Firstly, on this topic or this experiment, the subject is the pipe. Okay, the pipe. So what we investigate is we want to investigate the friction loss in the pipe. What happened in the pipe? So what if there is some changes in the pipe? Let's say there is the diameter of the pipe is not consistently same. What if there is one big and one small? What happened on the flow? Supposedly, maybe if there some changes of diameter in the pipe, maybe it will happen some turbulent and laminar flow. So there we want to know what is the pressure of the changes. Okay, we want to know what happened if there are changes in the pipe. Is it there will have the changes on the flow rate and the velocity? Okay, so in this experiment we will know how it will happen. So if we will in this experiment we also will observe what happened if there is a changes if we apply of different angle or different geometry of pipe. So what will happen in this flow of fluid in the pipe. The point is, we want to know what happened for us, or when we in industry, we can control and adjust the problem, or we want to increase the efficiency, the flow in the pipe. Let's say I give an example where it is our pipeline at the house for our tap water. So it's coming from we know it comes from the process from the river. So the river come to the tank container, the big tank, and it will distribute the water to our house. So there we want to know how possible from far of the container of the tank that to keep our water clean and distribute it to our house. So is there any losses in the process to distribute in our house? Okay, from here we know, is it there is a friction loss in our. So now, what is the problem on this experiment? So when we do this experiment, we know we must make sure that the pipe joint is connecting together. Okay, then we will make sure all valve is can be used or open, so that all the fluid can flow through the pipeline. Then we want to investigate the pressure using the pressure sensor. Okay, then we need to calculate the head loss and the friction coefficient through the. So the objective is that we need to investigate the head loss and the friction due in the pipe. Like I say, we want to know that is there any losses in our pipeline. So and then we want to know, is there any changes on their flow rates and velocity in when this process is running. Okay, that's how we can know the water from our river and process and supply to our house, how it can be. Okay, so this is our setup for experiment. Okay, like I said, this setup, we want to know how there is any changes in our pipeline. So the first thing is we have here of course the fluid frictional apparatus. Okay, then we have a hydraulic bench, then we have pressure sensor here. Okay, actually this pressure sensor. Okay, okay, this then we have indicator lah, okay, to take the data. Okay, how we want to run this experiment is, the first thing is we need to open all the valve that was closed. Okay, so that when we switch on the switch, this the fluid can be flow to all the pipeline. Okay, then we need to adjust the control valve. Okay, here the control valve we show so we can control the flow rate of the water. If you want be high, you can put it high, or depend on how you set it up. Okay, then after we the system is running, we can see that there is the water coming out from the system, so that we know the system is running and the pump is running as well. Okay, so after we know it is running, close the valve that we not using it. Okay, so let's say we use the straight pipeline. Okay, actually this is, there is something different pipe. This is small and this is big, so it will form a turbulent flow. So we will investigate this pipeline. So let's say we use this pipeline. Okay, after we close the pipeline that is not using, so we let it run on the pipeline is open. Okay, then we put up the pressure sensor. This is pressure sensor, so we put it up. One is on the small pipeline pipe, and this another sensor we put in on the bigger pipeline. So it will indicate it on the indicator here, so we can take the reading. So if we want to investigate on the other pipeline, so we just close, just repeat the step like I say before. Just close it and open when you need it. Okay, so that's all from me. Assalamualaikum warahmatullahi wabarakatuh, and thank you.
So, hello, good morning. My name is Hadi Berdaduni, and I'm Mr. Rajid with the metric number of MA19245. Today I'll be presenting on chapter 2, which is the theory. First of all, is we will try to define what is frictions. So, frictions is a force between two surfaces that are sliding or trying to slide across each other. So we take an example, which is when you try to push a book along the floor, frictions makes this difficult. So yes, frictions will always work in the direction opposite to the direction in which the object is moving or trying to move. And then frictions inside a pipe causes major losses, whereas minor losses occur when a part, valve, bend, or other interruptions occurs. So you will investigate the effects of large and minor losses on water flow in pipes industrialistic. So next is what is continuity equations and viscous fluid. So continuity equation is the mass of fluid going into the pipe would equal the mass of fluid going out of the pipe. And the viscous fluid is also known as Newtonian fluid. But what is Newtonian fluids? So it is such as water or oil or characterized by a viscosity, for example, the ratio between shear stresses and shear rate that is independent of shear rate. So these fluids display a linear relation between shear stress and shear rate. So lastly is the pipe friction loss calculations. So the flow of fluid through a pipe is resisted by viscous shear stresses within the fluid and the turbulence that occurs along the internal pipe wall, which is dependent on the roughness of the pipe material. So that's all from me. Thank you.
Assalamualaikum, my name is Nurul Amira binti Muhammad Nasir. My metric ID is MA19291. Okay, for this lab 3, friction losses in piping system, I will explain about my parts, that is chapter 4, result and graph. Okay, this data we got for 4 types, that is straight line, elbow 90 degree, bend pipe 90 degree, and bend pipe 45 degree. Okay, for first condition, we have straight line pipe. Okay, in this table, we have 6 data. For group 1, table 1, we already have the volumetric flow in initial unit, that is meter cube per second. But for group 2 and group C, we have the original unit, that is liter per min. So we have to convert the unit liter per minute into meter cube per second to get the exactly line graph after this. Okay, after we convert the unit and we do calculation, we got this data. Okay, then we plot the graph on the next slide. Okay, this is the straight part line graph. As you can see, there are minor bumps occur in the line on the line. So we know that there is less friction losses occur in straight part line graph. Okay. For elbow 90 degree, this is our second condition. Okay. As same for straight line pipe data, from group 2 until group C, we have to convert its unit liter per min into meter cube per second. And we calculate, then we got this data, we construct the graph. Okay, this is the shape of the line graph for elbow pipe 90 degree. As you can see, there is more higher bumps occur in this elbow 90 degree pipe. So we can indicate that there is more friction losses occur in this kind elbow 90 degree piping system. For third condition, we have bend pipe 90 degree. Okay, for this third condition, as same for data from previous two condition, from group 2 until group 6, we have to convert the volumetric flow unit liter per min into meter cube per second, and we got this data. And we plot the graph, we got the shape of the graph like this. More slightly decrease the formation of the bump than the elbow 90 degree. So we can conclude the bend part 90 degree is less loss friction than elbow 90 degree. Okay, and for fourth condition, the last condition, we have bend part 45 degree. From group 2 until group 6, we also have to convert the volumetric flow liter per min into meter cube per second, and lastly we plot the data, and we got like this the data. So there is also occur the friction losses due to piping shape system.
Assalamualaikum, my name is Muhammad Izzuddin bin Mathematics. My matric fact number is Mathematics 09. Today I will talk about the question. So let's start the question. So firstly, the first question is to explain how the strain got set the question. So firstly, strain got is a sensor that system sense with type force. So it transforms a pressure and the pressure box into reciprocal system to get the reading. It's really utilized to get the reading data. So for the second question is what will happen to the step loss. The first question is the diameter of the pipe is decreased, and the second question is the length of the pipe is decreased. So for the first question, the head loss is inversely proportional to the diameter of the pipe. So if the diameter of the pipe is decreased, so the head loss is increased. For the second condition, the head loss for fluid flow is directly proportional to the length of the pipe. So if the length of the pipe is decreased, so then the head loss will decrease also. That's the question 2. So for the third question, what are the two types of major levels typically associated with pipe flow? from your experimental result, which one is the most significant loss occurred by the following law? So, there are two losses, which is major losses and minor losses. And the most significant losses are that we occur by the flow or the following another part is major loss. Major loss is a head loss due to friction in the part and back. For the question, how can you find the value of minor loss coefficient from the experiment? For this question, the minor loss coefficient means is the change of velocity due to friction to pipe, pitching, and rock. Okay. So how to measure the minor loss coefficient is measuring the pressure difference between the two pitch points and the straight pipe with a scalar cross section for a straight flow. That's how to find the value for the minor loss. So for the pitch question, which is the last question, compare with the critical Reynolds number. The theoretical value of which the question for the most equivalent the most significant value. So the difference between the two. So for the Reynolds number for the laminator is about 2200. For the equivalent is 4000. So between 2200 and 4000, it is a transition machine. So the result of the difference between laminate and tubular is the flow pattern, change of the flow pattern, and the displacement and the change of velocity. Different result. So that's all from me. Thank you.
Assalamualaikum. My name is Nurul Amira binti Muhammad Nasir. Metric ID is MA19291. Okay, in this lab 3, friction losses due to piping system, I'm going to story about chapter 5, conclusion. For conclusion, this experiment is to determine conduct to determine friction losses in the pipes with different conditions and shapes with different level of degree, such as shape of bend pipe, elbow, straight line, or different level of degree like 45 degree, 0 degree, and 90 degree. We measure these friction losses based on this condition. Okay, the main purpose for this experiment is to investigate the head losses due to friction in a pipe to determine the friction factor for laminar and turbulent flow. Okay, in this experiment, we use fluid friction apparatus, hydraulic bench, pressure sensor, data measurement, and data acquisition. Factors that affect the head losses. Number 1, viscosity of the fluid like kinematic and absolute viscosity. Number 2, size of the internal pipe diameter. Number 3, internal roughness of inner surface. Number 4, change in elevation between the ends of the pipe. Number 5, length of the pipe. How can we overcome friction losses? Okay, we can overcome the friction losses by reduce the interior surface roughness of piping system. We can also increase the pipe diameter of the piping system. We can also minimize the length of piping system. And lastly, we can also minimize the number of elbow, tears, valve, fitting, and other obstructions in the piping system. The more straight, the more better. Okay, thank you.